So in this question, you're given f of x is equal to 1 plus x if x is not, x is less than or equal to 2, 5 minus x if x is greater than 2. You're asked to show that f of x is not differentiable at x is equal to 2. So you can do it in two ways. So one is the subjective way, one is the objective way. That is, if you want to derive this from the first principles, you can do it in one way. If you are looking at just the answer, that is, if you are looking at how to solve this in objective examinations, you can do it directly. So let us look at both the process. So the first process is from the first principles. So we know that the differentiation of f of x at x is equal to 2 is limit h tends to 0 f of a plus h minus f of a by h, or limit c tends to a f of c minus f of a by c minus a. So you can use any of these definitions. So first let us use this definition. So you need to find the right limit and left limit and see whether both are same. So what is the right hand limit? It is limit h tends to 0 plus. So f of, you're looking at x is equal to 2. So a is 2. So this is the formula for f dash at a. I want f dash at 2. So f of 2 plus h minus f of 2 by h. So as h tends to 0 plus, 2 plus h is slightly more than 2. So if you want the functional value of f of 2 plus h, you have to go here. So that is equal to limit h tends to 0, 5 minus of 2 plus h minus f of 2, because at equal to 2 this is the function which works. 2, if you put 1 plus 2 is 3 by h. That is equal to limit h tends to 0 plus 5 minus 2 minus 3. 5 minus 2 minus 3 is 0. So minus h by h, which is equal to minus 1, because h and h gets cancelled. It is the right hand differentiation of f of x when x is equal to 2 is minus 1. So now let us find the left hand limit. So limit h tends to 0 minus f of 2 plus h minus f of 2 by h is equal to, so if h tends to 0 minus, so 2 plus h is 2 plus some negative number, that is, this number is slightly less than 2. So if you are looking at f of 2 plus h, you need to go to this function. So this time limit h tends to 0 minus, so 1 plus 2 plus h minus f of 2 is 3 by h. So this time 1 plus 2 and minus 3 gets cancelled. That is equal to limit h tends to 0 minus h by h is 1, which is equal to plus 1. So the right hand differentiation is minus 1, left hand differentiation is plus 1. Hence the function is not differentiable at x is equal to 2. Hence fx is not differentiable at x is equal to 2. So now if you want to do this directly, you can use your differentiation formulas also. So if you go to the right side of 2, it is x greater than 2. So this is a polynomial function, you can differentiate it directly. So what is the differentiation of 5 minus x? So d by dx of 5 minus x is nothing but minus 1. And what is d by dx? On the left hand side, 1 plus x is equal to plus 1. So as you can see, these numbers are exactly same as the numbers which you got here. So what you can do is, you take the functions and differentiate them using the formulas that you know, using the differentiation formulas that you know. the differentiation of x is 1, differentiation of minus x is minus 1. And if the numbers are different, obviously you can see that the function is not differentiable. But if the numbers are same, it doesn't mean that the function is differentiable at x is equal to a. You need to have further checks. So let us take another question on this concept.